So what we've got here essentially is a physical interface for exploring graph data, such as scatterplot data or scatterplot data that's put into buckets or different categories. And we have an independent X and Y control to navigate your location on the graph. And the feedback system that you're going to be using is sonification. So you'll be exploring the graph through sound, through both a sonification of each point's value, but also a point estimation sonification that will help you find a particular point on the graph.
And so, to add on to that a little bit, basically what happens is as you move, for example, we can move the x coordinates here. As we move them, then what happens is that you will hear the points along that x line, along that x-axis. If you have the ability with the interface to lock your x coordinate in place and then move the y-axis, and as you do that, you can hear you can find your point. You can estimate exactly where you are. So the sound not only tells you about the graph, but also lets you pick a point on the graph. For example, in the balance exhibit, it could be the point that maps to your balance, and then by moving up and down the y-axis, you could find exactly where your point, your balance is. And since you will have heard everybody else's balance along the way, you not only know about yourself, but also yourself relative to the other data points on the graph. And if you want to explore that through a non-auditory mean, you can see here that we have a physical interface as well that maps to the digital domain. So we have a Cartesian coordinate graph which has been laid out in a grid pattern, and then as a physical overlay on top of that, we have intersecting x and y lines which are perpendicular and they're movable in free space, which means that as soon as you map with using audio where your point actually occurs, you can take your hand and follow. You're fine. You can take your hand and you can take your hand and follow the y line, or you can take your hand and follow the x line to exactly where your point is and have a physical mapping for what you're hearing through your ears.
Which is a shockingly similar interface, well, with some obviously major differences to the, like they're kind of doing with sound in a tactile plot what we were doing with vibration.
Now one question I have for you is, when you talk about being able to figure out where you are, does it say like x2, y1 or something like that? Or
no, so it's sonification and verbalization together. So for example, as you move along the x-axis, you might hear something like, if it was a parabola, right, if there was a parabola here, let's say, then you would hear right? And as you go across, you can get the trend of the data. Now, if you want to know where your data point is, we can offer a button on the exhibit that sets it in the mode that allows you to find your data point, and then when you move this line, which I'm not allowed to move, what you will hear is your distance from your point mapped to pitch. So you won't hear about the data, you'll only hear about your one point, so you'll hear something like this. And the highest pitch maps to your point, so that's how you know to stop moving this bar. And it's very easy, research has shown, and a lot of documented research, that high pitch is very easy to determine. And so what you can do is you can find where your point is with this bar, and you can learn about all of the data with this bar.
Oops, sorry.